Ladies and gentlemen, the Corona Free Classroom Network proudly presents the anatomy of the respiratory system with your host, Gregg Thompson. Hey, how y'all guys doing? I miss you guys. I wish we could be together, but it is what it is. So, respiratory system, here we go. Respiratory system, this is the organ system in your body that is going to be responsible for getting oxygen into your body, which you need to process. Remember, we talked about cellular respiration back in the fall. Cellular respiration is the ability of your cells to break down or to combine sugar and oxygen, put them together to create ATP, the energy molecule, and the byproduct of that is that it releases water and carbon dioxide. Okay, so your respiratory system is involved in getting oxygen into your body and getting carbon dioxide out, and that's what you need. You got to stay alive, right? That's how we do it. So, in order to do that, we have to have a certain organ series of organs. Remember, tissues combine together to form organs. Organs combine together to form organ systems, and organ systems combine together to form an organism. So this is an organ system. Okay, it begins in your nose, way up here. All right, that's where it starts. Your nasal passages, your mouth. Even though you can breathe through your mouth is technically not a respiratory organ. It is a digestive organ. We'll talk about that in the video on the digestive system. So, your nose, breathing starts in the nose. As you breathe in, draws air in. There's actually small bones called the turbinals. Three sets of bones covered with membranes. That helps to warm and moisten the air before it goes down and hits your lungs. You don't want all that cold air. I lived in Minnesota for a couple of years. It gets really cold in the wintertime, 10 below, 15 below. You don't want that cold air going into your lungs, freezing the moisture in your lungs. You got to warm it up before it gets there. And that's the job of the turbinals. They also aid in the sense of smell. They're going to pick up molecules of whatever that are drifting around in the air. You're going to get them into your nose. And once you get them in there, that's going to send off little nerve signals to your brain, allowing you to have a sense of smell and detect the things that are going on around you. So the first part of the first organ is the nose, the nasal passages. They're going to help you to warm and moisten that air. The air then goes back into an area called the pharynx. The pharynx is a common area that is shared by both the digestive and the respiratory systems. Okay, this is why if you're drinking Coke and you laugh, the Coke comes out of your nose, because they are connected in the pharynx. The pharynx is the very back of the throat. If you were to open up your mouth like that and look in the very back, you'd be looking at the pharynx, because both air and food go through that area. Now, just below the pharynx is this thing right here. That thing right there. That is called the larynx. The larynx is this big cartilage thing, and it's actually kind of creepy. You can grab it and you can actually move it like side to side like that. Don't do it too much. You need the larynx. It's good. It's good stuff. The larynx does contain, it's a large cluster of cartilage, a large kind of a cartilage box. Just below that is the trachea. We'll talk about that in a second. That large cartilage box is where your vocal cords are contained. Okay, males during puberty, that larynx expands in size, which is what produces the lowering of the voices in males. Why males tend to have a deeper voice than females is because of that enlarging of the larynx during the time of puberty. Okay, so that brings the air into here. Now, just at the top, your larynx is in the front. Your larynx and trachea. Trachea is the tube just underneath the larynx. You can feel it right in between the two collarbones, right there in that little notch, right there. If you push, it's kind of hurtful. Don't do that too hard. That is the trachea. The trachea is the air tube. It's going to carry the oxygen or the air down into your lungs. Okay. The trachea and the larynx, they sit in front of your throat, right? They're the part right here in the front. Just behind them here is your esophagus. The esophagus is part of the digestive system. That is what's going to carry the food from your mouth down into your stomach, okay? Now there's a little flap that sits on top of that. Pretty much it stays open all the time. That flap is called the epiglottis. The epiglottis is there when you swallow. As you swallow, part of the swallowing reflex is that trachea, the larynx, lifts up, and that epiglottis closes over the top of it so that the food from your mouth slides over and into the esophagus to make it down into your stomach. What you don't want is for that not to happen and food to go into your trachea. That would be bad. That's what we call choking. Choking, no bueno. Okay? So, this is why, by the way, Mom always tells you, don't talk with food in your mouth. It's not just rude, it's deadly. Because if you're talking, you're using air, and if you're chewing, you're using food. And if your body gets the two confused, you could have food go down the wrong way, and that can produce what scientists call death. That can ruin your whole day. So don't go there. All right, so what you do, if you actually get a mouthful of saliva and you go to swallow, you can see that larynx lift up and come back down, helping to close that thing off, get the epiglottis over the trachea so that whatever's in your mouth is being put down into your esophagus and not into your lungs. The only thing you want going in your lungs is air. That's important. Once you get the air down into your trachea, it goes down. Trachea is a small tube. It's only about that long. It has C-shaped pieces of cartilage that help to hold it open. They're not rings of cartilage. They're C-shaped. The back of the trachea is actually left open so that as food goes down your esophagus, it has a place as that esophagus expands. Your back of your trachea is fairly flexible, and it allows that expansion as the food is going down. This is why sometimes you can feel like when you've swallowed something that, oh man, that's stuck in my throat. It's just as it's moving down, it's bulging into your trachea, and you're kind of feeling that constriction, and that's part of what gives you that feeling as you're swallowing food. Once you get air down in through your tracheas will split into your bronchial tubes. Bronchial tubes, you have a left and a right bronchial tube. Those will carry the air into your left and right lungs. As you carry them in there, that bronchial tube will then split into smaller tubes, the secondary bronchial tubes, and then the tertiary bronchial tubes, and then eventually to the tiny little bronchioles. And each of those little bronchioles will terminate in a little cluster of sacs that are called the alveoli. The alveoli are these little tiny thin membrane, one cell thick of epithelial tissue that allows for that gas exchange. Each of those little sacs, those alveoli, are surrounded by an intense ball of capillaries. Again, one cell thick capillaries allow for easy exchange. So as the concentration in oxygen is greater in the air that you've just breathed in, that concentration of oxygen, the oxygen will then diffuse into your blood, attaching onto the red blood cells. Your red blood cells will then carry those back. That's on the video series when we talk about circulation. We'll get to that later, okay? And then the carbon dioxide, which is in higher concentration in the plasma of your blood, that will diffuse back in through those membranes and get into the air before you exhale. So when you inhale in, air goes in, dead ends into the alveoli, and then you have diffusion that goes into the capillaries. Those capillaries, carbon oxygen diffuses into the blood. The blood then, carbon dioxide then diffuses from the blood back into the air, and then you breathe out. All of this is managed, by the way, by the diaphragm. The lungs themselves are passive. The lungs themselves do not do anything on their own. What causes them to change size as you breathe in or breathe out, what causes them to change size is your diaphragm. The diaphragm is a muscle that stretches from right about here, right about the bottom of your rib cage, kind of all the way down like this, dividing your thoracic cavity from your abdominal cavity, two areas in your body. All right, as the diaphragm contracts, it pulls down that increases the volume of your thoracic cavity, your chest cavity, increases that volume. As it increases that volume, it lowers the pressure of air in your lungs. And since nature likes everything balanced, it's going to send the high pressure air from here in through your nose, your mouth, through your trachea, down into your lungs to balance that pressure out. That's what causes inhalation. When then you relax your diaphragm, that allows the air to go back out. Your diaphragm goes back to normal. That decreases the volume of your chest cavity, increasing the pressure inside of the lungs, forcing the air back out of your lungs and back out into the atmosphere, right? So your breathing is all regulated based on that diaphragm. We have dead-end lungs. Remember we studied the birds? They have that awesome flow-through series. We don't. We're mammals. We have dead-end lungs. Breathe in, breathe out. Simple as that. All of this is going on. You're fairly efficient at absorbing that oxygen. And part of the reason is because if you were actually to take each of those little grape-like alveoli out of your lungs and peel them open and lay them out, the surface area inside of your lungs, that is the surface area inside of the alveoli, is in fact about the same size as a tennis court. That's the amount of surface area you have in your lungs that you're using for oxygen and carbon dioxide exchange. It's pretty darn awesome that all of that, you have a tennis court inside of your lungs. That's just pretty cool. So what is it now that triggers that breathing process? What triggers the breathing process is not your desire for oxygen. That's not it. What triggers your desire to breathe is the buildup of carbon dioxide in your blood. I'll show you what I mean. Okay. I just put a demand on the muscles. The muscles then had to generate tons of ATP so I could run up the hill and come back down, breaking that tree as I went. That was pretty scary. I thought it was going to hold me. So what happened is, as I generated that, my body was creating all kinds of ATP that was generating elevated levels of carbon dioxide that get released from my muscle cells into the blood. As the lungs pick up on that increased carbon dioxide, my body said, oh no, carbon dioxide, bad, no bueno, it's a poison, we got to get rid of it. And then therefore, the urge to breathe steps up, it increases. And it increases to get rid of the carbon dioxide. That's the whole purpose of it. In the meantime, I'm getting the oxygen back in, which is good, but it's the desire to get rid of the carbon dioxide. That's the thing that triggers it. This is why, if you're having the breath holding contest and you're going underwater, this is why if you go underwater, you start to feel that burn. If you blow a little bit of air out as you're underwater, just a little bit, it lowers the carbon dioxide levels. And for a brief moment, it releases that urge you have to breathe in. So if you're doing the breath holding contest in the pool this summer, make sure that as you're underwater, you blow a little bit of air out every so often, decreasing carbon dioxide levels and decreasing, therefore, your urge to breathe. So that's the anatomy of the respiratory system. You have your nasal passages, your nose up here, goes down through the pharynx, into the larynx, into the trachea, down from the trachea into the bronchial tubes that terminate in each lung in those little tiny sacs called the alveoli. All of this is regulated, the breathing, by the diaphragm, and the diaphragm is told how fast to breathe and how fast not to breathe based on levels of carbon dioxide in your blood. And that, my friends, is the respiratory system.